Okay, today's lesson is on, again, finding limits algebraically. This time we're going to look at examples that use complex fractions. So anytime we're dealing with fractions, we're probably going to be dealing with adding or subtracting them, and thus common denominators. So let's take a quick look back at adding fractions or subtracting fractions with common denominators. So a really basic example, 2/3 plus 3/5. If I need to add these, I need to have common denominators. So basically what I'm going to do is this side has a 3, this side has a 5 in the denominator. So I'm going to multiply by the opposite of each of those on top and bottom. So when I multiply fractions, I multiply across. So this would be the same thing as 10/15 plus 9/15, which would give me a total of 19/15. We also might have a more difficult example where we might have something like 3 over x minus 2 and plus 2 over x. So similar idea, this side has an x, so I need to multiply the opposite side by that. And then this side has an x minus 2, so I'm going to multiply the opposite side by that. And again, multiply across the top. So when I multiply the left fraction, I get 3x. And then when I multiply the second one, I get 2 times x minus 2. I'm going to do a quick change on this. I'm going to make this a minus so that we can see what happens when we have a subtraction. So this would end up being minus 2x minus 2. And then the common denominators, because we're trying to combine these, would simply be x times x minus 2. And you could multiply those out, but again, more than likely with these examples, we're going to have a 0 over 0, which means a whole, so something's going to need to cancel, and more than likely it's going to be whatever that fraction is on the bottom. Alright, so now to simplify the top, I get 3x, and then I need to distribute this, and when you have a minus, you got to remember to distribute the negative. So I end up with minus 2x, and then plus 4 over x times x minus 2, and the top simplifies to be x plus 4, let's write over here, x plus 4 over x times x minus 2. So again, nothing cancels out in this case, but later on in the examples that you'll see, they probably will. So with that kind of background knowledge on common denominators, let's take a look. So as I said earlier, if I try direct substitution, which is always your first step, in this example, I end up with on top negative 7 plus 7, which is a 0. And when I plug that in on the bottom, I end up with negative 1/7 plus 1/7, which is also 0, which means whole. So I need to do something to figure this out so that I can cancel that out and then try direct substitution again. So looking at the denominator, I can see I've got this fraction inside of a fraction. So what I'm going to do is, this side has an x, so I'm going to multiply this side by x on top and bottom. This side has a 7, so it gets multiplied by 7 on top and bottom. So now it's time to rewrite the limit. Limit as x approaches negative 7. The top didn't change, so I'm just going to leave that. But then I end up with 7 plus x over 7x. Alright, so now I have one fraction over another fraction. Whenever I have that, I'm going to multiply by the reciprocal of the denominator on top and bottom. And what that will do is cancel out the entire bottom. 7x's cancel out, 7 plus x's cancel out. Which, if I rewrite my limit now, I get x plus 7, and that's really over 1, so I'll write that, times 7x over x plus 7, and it's actually written as 7 plus x. But we all know that 7 plus x and x plus 7 are the exact same thing, so those will cancel out. leaving me, that's where that canceling out comes in with the 0 over 0. So leaving me with the limit as x approaches negative 7 of just 7x. And I can do direct substitution again. And when I do direct substitution, I get negative 49. And that is your answer to that limit. Okay, let's try example B, and then I'll let you guys try a couple on your own. All right, this negative 1 is really negative 1 over 1. So there's my complex fraction. So I'm going to multiply. This side doesn't need to be multiplied anything because it's just a 1 in the denominator. This side needs to be multiplied by x plus 1. So I'm going to multiply by x plus 1 on top and bottom. I'm going to rewrite my limit. Limit as x approaches 1. So I get 2x minus, and then I'm going to remember to distribute that over x plus 1 all over x minus 1, and then I'm going to go ahead and throw a over 1 for that bottom part, just so that I remember that it's a fraction over a fraction. All right. When I clean up the top, I end up with 2x minus x, which is just x. And then distribute this, I end up with minus 1 over x plus 1 all over x minus 1 over 1. So I've got a fraction over a fraction, which means I'm going to multiply by the reciprocal. 1 over x minus 1. Again, 1's cancel, x minus 1's cancel, and in the top, you'll notice the x minus 1's cancel as well, leaving me with just 1 over x plus 1. So limit as x approaches 1 of 1 over x plus 1. I can try direct substitution again, and when I try that, I end up with 1 over 2. That's a number. So that's my answer. So again, just as a recap, when we're trying to find the limits here, again, we should have tried at the beginning. I forgot to mention that. If I try direct substitution, I get 0 over 0. That's why we went through this whole process. And then rationalizing using those complex fractions. So go ahead and pause now and work on the next two examples, and then check your work. All right, I will assume that you have paused and done these two problems. Let's start with example A. Again, direct substitution gives us 0 over 0. This side has a 2, which is why I multiply the left by 2 over 2 and the right by x plus 2 over x plus 2. And then when I do my algebra, I end up with down here with negative 1 over 2 times x plus 2. I try direct substitution again, and I end up with negative 1/4. For example B, again, direct substitution gives me 0 over 0. So I multiply the left fraction by x minus 1 over x minus 1. I work through the algebra, and I do direct substitution after I cancel out everything, and I end up with negative 2 for my